Welcome everybody to my LeetCode Biweekly Contest 149 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we will be doing the contest live, answering questions and giving hints in the chat, so come join us every weekend for the contest. No code will ever be shared, no solution will ever be shared during the contest itself, but immediately after it ends, we will go through the answers for all 4 questions. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Okay, so I have a bit of a sniffle today. I hope that doesn't sound too weird to folks. I see people are streaming into the room as we speak. Alright, the contest is about to start in 1 minute and 10 seconds. Remember, register the contest. And we should be good to go very soon. Oh, today's problem of the day is actually easy. So there's not much to talk about there. We should be ready to go soon. 45 seconds. Just write the standard chat. Welcome if you just joined the channel. If you've never joined us before. The way this channel works is I'm gonna work on a contest on a separate screen. So if you don't see anything, don't worry. Just ask in the chat. Alright, and we are live. Good luck, everybody. We're ready to go. Okay. Reschedule meetings for maximum free time. There are 2 questions that look very similar. So I'm gonna look at them at the same time. But let's start with the first question. Find valid pairs of adjacent digits in string. Alright, come on, buddy. Four not found. Oh god. Are we back to DDoS? Hopefully we're not. We can't be back to the DDoS, right? There's no way. Oh my god. Come on. Alright, cool. Find adjacent pairs. Find valid pair of adjacent digits in string. You're given a string S comprising only of digits. A valid pair is defined as 2 adjacent digits in S, such that the first digit is not equal, so they have to be different. And the second digit appears in S exactly as many times as its numeric value. Okay, so the example is 2523533. So 5 appear once, 3 appears 3 times. So each digit in the pair appears exactly as many times as numeric value. Okay, so 2, 3 appears in exactly as many times as that unique numeric value. So 2 appears twice and 3 appears 3 times. That's what this is saying. Appear as many times as numeric values. And they have to be different. Okay, this is not too hard. Give it a try. If you have any questions, feel free to talk. Voice them in the chat. I will come join. I will come help you. If not, I'm actually working on a separate screen. So you don't see any action, don't panic. I am still alive. I'm not dead. Welcome, welcome. I see more people are streaming into the chat. Once again, if I'm not... Wait a second. If I'm not doing anything on the screen, that's perfectly normal. Because I'm coding on a different screen. If you oh god, this is so funny. If you need help, make sure to speak up, and I will attend to you. 1, 2, 3, 4. What is happening here? Alright. Cool. Alright, question 2. Reschedule meetings for maximum free time. You're given an integer event time denoting the duration of events where the event occurs from time t equals 0 to t equals to event time. Okay, you're also given two integers, start time and end time, each of length n. Integer array, start time, end time, represent start and end time of n non-overlapping meetings. You can schedule at most k meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. The relative order of all meetings should stay the same and they should remain non-overlapping. Okay. Return the maximum amount of free time possible after rearranging the meetings. Okay, so this is a mouthful. So start time, so event time is 5. So total amount of time is 5. K equals 1, start time equals 1, 3. Okay, start time equals 1 and 3. So let me see. So start time. This is a very awkward data structure. But basically, they put the start time and the end time in two separate data structures. 2 and 5. Okay, so reschedule the meeting at 1, 2 to 2, 3. You can reschedule at most k meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. Okay. So you can only rearrange at most one meeting. So if we move this thing here to this thing here, we'll have one continuous block like this. Okay. Return the maximum amount of free time possible after scheduling the meetings. So in this example, event time is 10, k equals to 1, start time is blah blah blah, output is 6. So reschedule a meeting 2, 4 to 1, 3. So if we reschedule 2-4 to 1-3, there's no meeting between 3 and 9. Wait, is the free time contiguous or not? I'm a bit confused. Does the free time have to be a contiguous block? Oh, snap. Sorry. I didn't realize my screen was... Oh, I see. I'm showing the wrong... I'm sorry. Thanks for letting me know. I'm showing the wrong... the wrong screen. Oh, snap. Let me fix that real quick. Okay, so now we should be on the right screen. I'm sorry about that. Thanks for letting me know, Okay, yeah. I was also explaining on the wrong screen too, which was probably worse than showing the code to question 1. Okay, so I'm a bit confused about this. Free time is contiguous, right? Is free time contiguous? Is free time the largest empty block? Continuous period of free time. Okay, I see. So free time is the largest block that is free. Okay, so presumably what you want to do is you want to sort of shift the blocks around, right? Shift the blocks around so that you have the maximum amount of free time. And essentially you only shift it sort of next to the previous or the preceding block. So let me think about this a little bit. But before that, let me also look at the next question. So question 2 and 3 have the same name, which makes me think they might be related. So I'm going to look at the second one. So question 3, these represent the start time of n non-overlapping meetings. Okay, so this is question 3 and this is question 2. I want to see if they're the same question. Okay, question 3 is at most one meeting. Question 3 is at most one meeting such as meetings non-overlapping. Oh, okay. So it's different. So question 2 basically you can reschedule K meetings. They still need to be in the same order. Question 3, you can reschedule you can move one meeting anywhere you want. So question 3 is one meeting and you can change the relative ordering of the meetings. So you can move one meeting anywhere you want. Question 2 is you can move up to K meetings but you must keep the order. Okay, this makes sense. Binary search. I don't think you need binary search. I don't think you need binary search. So if you think about it, right? You have a block of time. you have some meetings. Okay. So the idea is you need to move K meetings, right? So you want to move K meetings to create the largest contiguous block of time. So where do you want to move the meetings? Probably you want to move meetings that are next to each other. If you move like this one and this one, then they don't help. So let's say, for instance, let's say K equals 2. You want to move 2 that's side by side. You don't want to move one here and then one here. That's not gonna help you, right? That's not the best use of your meetings. So probably if you move 2 side by side, you're gonna move them all to the end here. So if you want to move these two, essentially what you want to move them is either both to the left or to the right. So essentially, you're free if you move these two to the left and they become here, then essentially your new free space is here. So the free space between this guy and this guy is going to be the distance between them minus the size of these two blocks. So you can calculate if I move these two, then I can calculate what is the largest contiguous space left. So you don't actually need binary search. I think it's a sliding window kind of problem. That's all I'm gonna say. Work it out. Try to work on it yourself. If you have questions, ask in the chat. Also, I could be wrong. So I have been known to be wrong. So give it a try. Yeah, interesting. Thanks. Yeah, good luck, Suju Patil. Let me know if folks need more help. Let me know. Meanwhile, I'm working on my other screen, so if you don't see any action, don't panic. Just speak up. You will see some action if you speak up in chat. What algorithm should I use? High value global GARC. Sliding window, yeah. Some kind of sliding window. Yeah. Example, unkeep world, yeah. So you want some kind of sliding window. Think about it. If K, in this example, right? If you see this example that I have here, imagine you have a bunch of 1, 2, 3, 4, 5 blocks. The idea is you want to, if you want to move K equals 2, let's say you want to move 2 blocks, you want to move 2 blocks that are next to each other. It makes sense. You don't want to move 1 block here and 1 block here. That's not going to help you. So you want to move 2 blocks that's next to each other. Probably what you want to do is just figure out the distance between here and here if you move the blocks. So it's some kind of sliding window. Yeah, and as usual, you need to take care of the boundary conditions. That's actually the most tricky part, the boundary conditions. One, two. All right. Just run this, see what happens. If you just join us, welcome to the channel. I'm suffering from a bit of cold today, so I'm sniffling. Okay, so I got a bug in my code. Trying to fix it now. Okay, let me read the chat. What is the approach for the second one? BTS Army. Oh, welcome back, BTS Army. I remember your name. Do you have any idea how can solve the memory exceeded? Depends on your algorithm. Depends on your algorithm. So I didn't do a binary search. I do some kind of sliding window. I did some kind of sliding window. Let me see if I can give a little bit more details. You know, I try to do that as time goes on. So you think about it as a bunch of blocks. The idea is you want to say you want to, let's say k equals 2, right? You want to move 2 blocks that are next to each other. There's no reason, it makes no sense to move one block here and one block at the end. So what you have essentially is you're gonna fix this block and then you'll fix this block, right? And you calculate what's the space between these two. So this is block ID 0, this is ID k. So the space, if you fix these two blocks, the space between them is equals to this guy's end, this guy's start, minus the length of all the blocks in between. So these two guys. So you can calculate that easily, right? So once you've done that, you can then say, all right, I'm going to move on to the next pair of blocks. This one and this one. And the distance between this is equals to a distance between them. You're going to move this block here, and then you're going to move this block here. Right? So distance between this and this minus the total size of the blocks between them. So you keep moving these two arrows all the way until you reach the end. So it's some kind of sliding window problem. I hope that makes sense. Okay, let me read. In the question 1 is mentioned the first digit is not equal to the second. Why is the... Okay, let me go through question 1 real quick. So question 1, you're supposed to return a pair. You're supposed to return 2 digits. Yeah, first digit is not equal to second. Yeah. So you return 2 digits. The first digit is 2 and second digit is 3. So you have to return, yeah. Pretty much, you have to return a pair. Like PHR said. Okay, cool. I'm gonna go back to working on my problem. I have some kind of bug with my sliding window. I need to fix that. So 0, 3, and then 2 and 5. Okay, that's correct. So window, window Okay. Three. Okay, k equals to 1. Yeah, let me look at the... Bro, I got the code. Okay, I'm going to... Yeah. So yeah, so unfortunately we don't share code here. Just a reminder, we don't share code on this channel during the contest. Yeah, so I appreciate you for trying to help, but we don't share code during the contest because we want everybody to do the contest, and we want to make sure there's competitive integrity. So sorry about that. I do appreciate you trying to help, but we'll do that after the contest. Yeah. Because we want everybody to try the contest on their own, right? We don't want people to self copy and paste the code. Yeah. If you want, feel free to give hints in the chat. I think that's the best way to help everybody. You get some hints during the contest, and then you try yourself and then learn. Okay. I think I got my answer, but I want to create some test case that is a bit more complicated to test it. Okay. Yeah, I think the test cases are not so the test cases for question 2 are a little bit biased, I think, because because in question 2 k is always equals to 1. Except for the weird sort of border case at the end. So I would recommend you make your own test case to test your code. Just to make sure everything runs as you expect. All right. Okay. Alright. I think I got it. I think my answer is correct. (19 minus 6). 21 minus 8 is 13. Okay, cool. I think my answer is correct. Gonna run it. I've been so paranoid with the wrong answers recently because I lost a lot of points to the wrong answers. Damn it. Damn it. I got a wrong answer. As I said it, I got a wrong answer. Maybe to check your boundary cases, guys and girls. I know most of you are guys, but remember to check your boundary cases. Alright, at last, managed to get it submitted. Question 3. Question 2, got it submitted. Okay, question 3. Wow, that really took a while. Okay, question 3. You're given an integer event time denoting the duration of events. You're also given two integer arrays, start time and end time. Okay, so question 3 is the same as question 2, except there's two differences. One is you can reschedule only one meeting, reschedule at most one meeting, and the second difference is you can change the relative order. So essentially, instead of shuffling meetings around, you can take that one meeting and can stick it anywhere you want. Okay, you can stick that one meeting anywhere you want. So for instance, this is my one meeting, 1, 2. I can take this one meeting and put it like literally anywhere else. Okay, this is a bad example. So, oh, this is still not a bad example. Yeah, so these two examples are not great examples. Okay, this is a good example. So, let's say you have 4 meetings, 0, 1, 3, 4, 7, 8, and 9, 10. What you could do, previously what you could do is you can only shuffle this guy to the left or to the right, right? But now what you could do, you could take this guy, just jump all the way to here. So you can slide them in any other box, any other slot you want. Yeah, you can slide them in any slot you want. So that's the difference. And you can only do it once. So this is not that different from the previous question, I think. It might be a little bit easier. So think about along the same veins, right? If except that k is now equals to 1. There's only one block. So, you take a block, what you want to do is slide, just take it out and put it somewhere else. So you need to figure out A, can you put it somewhere else? And if you can, what is the remaining space left? So let's say you have between this green and this yellow block, this pink block, you want to move it somewhere else. First, you need to check that there is a space for you to move, right? If it was continuous all the way here, if the third block is this whole thing, then you cannot move because there's no more space. First, check, is there a space? If there's space to move it somewhere else, then move it somewhere else. And what is the remaining contiguous free time after you move it somewhere else? So this one actually I think is a little bit easier. Okay, let me see the chat. Yeah, okay. Arvin, sorry. Yeah, DeepSeek solved it. Okay, don't talk about DeepSeek here. Don't talk about DeepSeek here, okay? DeepSeek is 100% against LeetCode contest rules. They state it very clearly. So don't try it and don't suggest it on my channel. Don't get me in trouble, guys. Don't suggest anything that has anything to do with cheating. This is not a cheating channel. Okay, I think I might just move on. Third question. Yeah, third question is easier. Hi, Nobido. Welcome. Third question is easier. Yeah, at least I think so. So I need to solve it first before I talk so much. So if you can do question 2, you can jump off ahead to question 3. Question 3 is I think is easier. Alright, I better do this quickly. So make sure I have time left for the last question. Let me just check. There's at least one event. There's at least 2 events. Okay. Hmm. Okay, let me check the chat. Need to iterate the code once through end meeting. Yeah. Just go through the code one time through end meetings. Just take the, look at each block. K equals to 1. You can remove one block. Look at each block and say, if I move this block somewhere else, what happens? Indices must be integers or slices, not a tuple. All right. I see more people are joining the chat. If you're new here, welcome. If you're a channel veteran, welcome back. Feel free to ask questions in the chat if you need any help. I will come attend to you shortly. I think question 3 is easier than question 2. I think that's been the consensus so far. If you're stuck on question 2, feel free to jump ahead to question 3. Gap I. Okay. All right. Okay. Let me just read the chat, see what's going on. B approach. So second one is some kind of sliding window. So think about it's some kind of sliding window. So think about it. If you have a okay, let me give you a better example. If, for instance, you have a bunch of meetings, and let's say if k equals to 2, you want to move 2 of them, you're going to pick 2 adjacent meetings. So of course, you're not going to pick this one and this one. That's not going to help you. You're going to pick 2 meetings that are side by side. Let's say this one and this one, or this one and this one. So what you want to do is you want to say this is your left, this is your right. There are 2 meetings in between. You scoot both of these meetings to one side, and you see what's the space left. So for every pair of meetings, I and I plus k, right? 0, 1, 2, 3. I guess I plus k plus 1. Between every 2 pairs of meeting, I and I plus k plus 1, you want to calculate what's the maximum space you have. And the maximum free space that you can create between these 2 meetings is the distance between their start and end minus the space occupied by all the meetings in between. So that's the basic gist of it. It's some kind of sliding window. That's all I can give you for now. It's some kind of sliding window problem. Yeah. I'm still working on 3. So once I'm done with 3, I'll let you know about 4. Alrighty. Okay. Block is 1, block is 2, space is 0, 1, 2, 3. That's not right. Okay. Okay, space is 3. That's right. 2 and 5. Space is 3. Okay, that's correct. Okay. Okay. I think I got it for question 3. Okay. I think I got it. Please, no wrong answer. Please, no. Ah, damn it. I keep getting penalized on the wrong answers. I'm kind of mad about this. 402 out of 695. Wrong answer. Yeah, sorry, I'm still on the third one. Sorry about that. I'll come to you as soon as possible. 113 seconds. So 0 1 2 4 0 1 2 4 5 5 6 5 6 and then 17 18. Event time is 18. All right. So 1 2 1 1 1 1 2 Wait a second. 0 1 2 3 range n. Why is it 0 1 2 3? Zero one 0 2 1 1. Oh crap. Start time minus end time. Oh crap. Oh, I had this very damn it, I had a really stupid bug. Alright. I had a really stupid bug. Really, really stupid bug. I sought the wrong order. Yeah, let me look at the chat. Sorry about that, I'm a little bit quiet. Yeah, I'm working on a third one. I have a bug. There's no code. There's no code. Sorry, cat speaking. I'm gonna. Yeah, we don't share code on this channel. If you, yeah, if you need help, ask on the chat. Once the thing is over, I would share the code. Sorry about that. Yeah, I need to finish up. Question 3. This is pretty horrible, to be honest. I have a lot of bugs in my code. The basic idea for question 3 is not that different from question 2. That's the basic premise. Yeah, I just have a really stupid bug. I can't find what the bug is. Okay. Okay, finally it's accepted. Oh god. That's pretty horrendous. Okay. Last question. Maximum cost of good caption. You're given a string caption of length n. A good caption is a string where every character appears in groups of at least 3 consecutive occurrences. So AAA, BBB, AAAA, CCC, they are good captions. AAA, BBB, CCC, okay, they're not good captions. Okay, so they have to occur in groups of at least 3. So at least 3 copies of the same character repeated. You can perform the following operations any number of times. Choose an index. Change the character at index to either the character immediately before or the character immediately after. Your task is to convert caption into a good caption using the minimum number of operations and return it. Okay, this is 100% a dynamic programming problem. 100%. 100% a dynamic programming problem. Minimum number of operations and return it. If there are multiple possible captions, return the lexicographically smallest one. So you have to find the minimum number of operations needed to make it a good caption, and then return the smallest one. If it's not possible to create a good caption, return empty string. Why is it not possible to create good caption? I think it's always possible unless the length of the string is less than 3. I think so. Because you can basically turn it into any letter you want. Alright. So, example, CD, CD. You can turn it into CCC, C. And this is a good caption. Okay. Okay, this is 100% a dynamic programming problem. Okay, I have no time to solve it. But basically, the way to do it is you go to each letter. You go to each letter and you say, if I change this letter, okay, after the first one, if I change this letter to something else, what would the cost be? So, for instance, let's say, let's see if there's a longer example. Yeah, so let's say CD, CD. CD, CD. Okay, so C, is nothing. So at D, what I want to do is, if I change it to C, okay, if I change this to C, my cost will be 1. If it's D, it'll be cost 0. Yeah, I guess, sorry. Yeah, I can change it to C or D, cost 0. I guess at this point this is sort of like these are both invalid, right? So now you reach C, right? When you reach C, you say, based on my previous letter, I can, if the previous letter is a C, the cost is 1. Okay, let me try and make this a little bit better. The cost is 1. Okay. Let me try and make it a little better. Let's say it's CCC. So CCC, okay? So this is valid. This first string is going to be valid. And what happens at the third character? What you can say is, I'm going to end with C, and my cost is 0. So the cost to make the third character C is 0. Okay, so at D, if I want this string to end with C, so the reason why I say end with C is because when I look at the next character, I only care about what the immediately previous character is, right? So when I reach this D, I can see that I can, with 0 cost, I can make the last character end with C and have a valid caption. I have a valid caption which ends with C and is 0 cost. So what I can do is, one, I can don't do anything. I have a valid caption. I'm now an invalid caption with a D. Or I have a valid caption. I keep it a valid caption, and I pay 1 cost, and it's going to end with C. So they are the two possible things I can do. Either turn this into a C, and I'll be this 0 plus 1, or I keep it as a D. Okay? So now I come to here. So C, I have, again, for each of the previous choices, I have 2 choices. So I could, in scenario 1, if I had turned the previous letter into a C and pay 1 cost, I can now continue this with a C. My total cost of this is still 1, and it's going to be a valid caption. Sorry, I should keep it as valid and not valid. Or I could keep it as a not valid. My last 2 is CD. And I pay 0 cost. It's going to be a not valid. Yeah, and then you sort of keep going on. In this case, the third case, you see that, okay, I can make the last one a valid caption. Yeah. So basically the idea is you want your caption to be valid at any one point, right? You want your caption to be valid at any one point. So to do that, the sort of the last character you can influence is 2 people before you. So if you're here, you're at this index, you only have to look at this guy before you and this guy before you. So your options are, okay, actually I don't even have to keep this. Yeah, this guy before you and this guy before you. And each point, what happens if for each character you store what is the cost to have a valid caption that ends with this character at this index with a certain character. So for instance, here at this index, For instance, what this thing is saying is that at index 3, I can end index 3 as a C with cost 1, and it's going to be a valid caption. So the cost 1 is because I turned this D into a C. Likewise, at this point, index 4, I can create a valid caption that ends with C for cost 1. So that's what this thing is saying. And what happens when you reach here is you look at yourself and the two people before you. You look at the two people before you. You want to be a valid caption, right? So your options are either you want to keep track of what valid captions there are here, right? So either you go to the one before you. The one before you ends with a C and it costs 1. So what you can do is you can say, okay, I can end with a C also. And it's going to cost me 2. Because I'm going to turn myself into a C. Or I can go back 2 steps. This guy ends with a C and it costs 1. That's the only valid option. And in this case, yeah, it's this case also ends with C. You basically turn yourself into C. Yeah, so basically what I think the strategy is some kind of dynamic programming where you keep track of all the valid options at every index and the index before it. You keep track of all the valid captions that end at this index with a certain character. And then you keep going until the end of the string. I think that's how you do it. Okay, let me read the chat. Sorry about that. It's gone on to second. Yeah, the 3 is a bit easier than second. Finally, second. Oh, you know what? You don't suck. Everybody takes some time to get things right. Okay. Wow. Okay, hang on. While the contest is about to end, but while I have everybody here, I would definitely appreciate it if you just click the like button on the video. If you've been enjoying this live stream today, just click the like button on the video you see on your screen. It should be the easiest way to help me out. If you haven't subscribed yet, feel free to subscribe. I stream every week, almost every week. I stream the bi-weekly contest if there's bi-weekly. If there's no bi-weekly, I'll stream the weekly. Yes, I'll be discussing solutions in 3 minutes. In 3 minutes, we'll be discussing solutions. So hang on to your hats. Metaphorical hat. If you're wearing an actual hat, you can hang on to that also. Let me see. Try brute force first. Yeah, I think. Did you get all of them? I did not get all of them. I'm pretty sure I know the answer for 4, but I don't have time to finish it. I have like 10 minutes left. I wasted too much time fixing bugs. But 4 is definitely a dynamic programming problem. I'm pretty sure of it. So it's dynamic programming problem. You go character by character. And basically you decide, okay, if I want to make this a valid string, right? What does it cost me to make this a valid string? Bro, will you be discussing tomorrow too? No, I'm not. I only stream once a week. If there's bi-weekly, I'll stream the bi-weekly. If there's no bi-weekly, I'll stream the weekly. So that's sort of my personal algorithm. Yeah. Today is not too bad, I think. I think the questions 2 and 3, they are not too difficult. You know, they're worth 5 points. Generally 5 points are not extremely difficult. 7 points is definitely a lot harder. Oh, you see, people finish the whole contest in 22 minutes. I don't know how they do it in 30 minutes. I just don't know how they do it. They finished the whole contest in 22 minutes. That's crazy. That's really crazy. Okay, we're almost to the end of the contest. Is a few more seconds left. Remember to like and subscribe if you can. I'm going to take a sip of water. I'm going to come right back. Alrighty, boys and girls, the contest has ended. I spent 22 minutes understanding a question. Yeah, sometimes the questions are very long. Yeah. Alright, let me just go through the YouTube script so that I can cut the video at this point, and there'll still be an intro for people who are jumping in to this timestamp. We are discussing solutions for LeetCode Biweekly Contest 149. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. I stream every week. I stream the bi-weekly contest if there's one. If there's no bi-weekly contest, I'll stream the weekly contest. So feel free to come by next week and let's code together. All right. So today is not too difficult. I managed to get 3 questions. I have some wrong answers. I'm not proud of it, but they are what they are. Post in the chat. Let me know if you. Yeah, just post in the chat. Let me know how many answers you got right. So we're gonna go through all the answers one by one. The first question. Question 1. Find valid pair of adjacent digits in string. You are given a string S of only digits. A valid pair has 2 adjacent digits in S such that the digits are different, and each digit appears exactly as many times as its numeric value. So what that means is, for instance, if you take this example, so 2523533, 2 appears 2 times, 5 appears 2 times, and 3 appears 3 times. 3 appears 3 times. So 2 and 3, both of them appear as many times as their numeric value. So these are both valid. And then we go through the list, right? We go through the list. Are there any pairs of adjacent digits which are both valid? So 2 5, nope. 5 2, nope. 2 3, yes. So this 2 3 here is correct. 3 3 is both digits are valid, but because they are same, 3 3 is not. So only 2 3 is correct answer. So how do you do that? The first step is actually to count the occurrences of all the digits, all the characters in the string. So this is just Python's way of doing it. You can just say counter, and counter will return a dictionary or hash, aka a hash table that tells you for every character how many times it appears in the string. So all I need to do is to use a for loop. I'll go through from n 0 to n minus 1 because we have adjacent pairs. So this has to be minus 1. The first number, second number, I will need to make sure that the 2 numbers are not the same. And their occurrences are equal to their numeric value. I have to cast to string here because the the characters are strings. In the hash table, the characters are strings and the values are integers. The numeric values are integers. So if they are, then return a plus b, which is a two-string concatenated. If not, return nothing. So this is pretty straightforward. I don't think there should be any questions about this. I don't want to see solutions of 3 and 4 yet. I want to try them on your own. Sure, I'm going to go through 3 and 4. You can, for 4, I don't have the solution either, but I'm pretty sure I know what the strategy is. So you don't have to listen in if you want to, but if you want, you can listen to the strategy and then try and code it yourself. It's up to you, depending on what you want, what helps you the most. Okay, so question 2. Reschedule meetings for maximum free time. 1. You are given an integer event time denoting the duration of the event. You are also given 2 integer arrays, start time and end time of length n. These represent the start and end times of non-overlapping meetings, where the ith meeting occurs during the time start time I to end time I. So you can reschedule k meetings anywhere they want. You cannot overlap. And what you want to do is to maximize the longest continuous period of free time during the event. The relative order should remain the same and they should remain non-overlapping. So for instance, let's say start time is 1-3, end time is 2-4. So start time 1, yeah, it's a bit weird because like start time is this and this, end time is this and this. So they put all the start time together and all the end time together. This 1-3 doesn't mean that there's a meeting from 1 o'clock to 3 o'clock. No. There's a meeting that starts at 1 o'clock, it ends at 2 o'clock. There's a meeting that starts at 3 o'clock, ends at 5 o'clock. So that's a little bit confusing. Okay, so the whole event duration is 5. 5 time. K equals 1 means that you can move at most 1 block. And your idea is to move, and by moving at most 1 block, you can sort of slide them to the left or right. You want to create the longest contiguous free time. So in this case, what you can do is you take this, you can slide it here, and then this thing will all be free time. And so your longest contiguous free time is going to be 2. So you take this block, this green block, you slide from 1, 2 to 2, 3. You slide from 1, 2 to 2, 3. And so your free time is now 0 to 2. So that's how you want to do it. So same thing here. Same thing here. If you have 3 meetings like this, you can take this meeting at 2-4, slide it all the way to 1-3. And then this will become your free time from 3 o'clock to 9 o'clock. So the answer is 6. Answer is 6. Well, these both examples, k equals 1. Sometimes k equals can be larger than 1. So for instance, if you have, let's just get more space. If you have a very long duration, you have meetings here, 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 and here, right? And let's say k equals to 2. So what you can then do is you can slide this meeting and this meeting all the way to here, and then this will become your free time. So one thing to notice is that essentially you always want to pick k blocks that are next to each other, right? It makes no sense to pick this one and then the one at the end. So when you pick, they're not random. You're picking, k meetings that are essentially adjacent to each other, consecutive meetings. There's no point in picking this one and this one, right? You want to create the most free time, so you pick a few meetings that are next to each other and then you pack them to the left or to the right. Okay, so if that's the case, then you can think of these two meetings as your left and your right. So you can imagine there's a pair of meetings, left and right. The maximum free time you can have between these two, this left and this right, is the end of left and the start of right, the space between them, minus the total size of all the meetings in between them. Right? Here there are two meetings. Whatever their size here, this is size 2, maybe this is size 3. So it's going to be this one minus this 5 units. That will be the maximum amount of free space you can have between these two meetings by sliding these guys around. So with that information, you can conceptualize this as a sliding window problem. You have a left and a right. There are k meetings between left and right, and you can slide the k meetings around, and you want to find out what's the maximum free time between this left and right. And then you move on, left plus or equals 1, right plus equals to 1, and you repeat again. So that's the basic premise. And your code will look something like this. You have left, I have L and R to indicate the indexes of the like these meetings. Note that the L can start not at meeting 0 but before meeting 0. So L can be like, the left edge, so-called, of the duration, right? And then you move these two guys around. So R equals to K. I have left denote the sort of left edge. So this will be left, and this thing here will be right. Okay, and I calculate the window. Window is the size of the number of blocks in between. So at the beginning, window is just the first k blocks. For each block I calculate the width of the block of the duration of the meeting, so end time minus start time, and I add them to window. And then what I do is I repeat. Let's take out all these things. Yeah. Actually, you keep them in. Okay, what I do is that I then repeat. L equals L plus 1, R equals R plus 1. I keep going while R is less than N. Okay, at each time, I just check, if R is, I make the left the new N time. I move the left to here. And the right, it goes all the way to the end until right is event time. And the window, I don't have to calculate the size of all the windows, of all the blocks again. I can use a sliding window technique of taking the previous window, I remove the last block, and I add the new block. And I calculate my score. My score is how much free time I can get by moving k blocks around between these two things. And I calculate the best my score I've seen so far and return it. So that's the basic idea. Yeah. Let me see if there are any questions. Can you only move it forward? No, you can move it forward or backwards. But if you always move it forward, it's fine, right? You think about a bunch of things on a line that you want to pack. You want to create as much free space around as possible. You can grab a few and then you shift them, just push them to your right. You create free space. You take the same sort of stuff. You sort of squeeze them to your left. They also make the same space. I've got a penalty of 30 minutes. Yeah, it's very obvious. Yeah, it's a little bit annoying. I got a few wrong answer because I was trying to run it and I clicked the submit button instead. And then it didn't give me the test case, right? So I was like, oh, let's click run again. So I got a few problems with that. So for Q3, I broke it down. Yep. Okay, let's talk about Q3 because people are already talking about Q3. So question 3 is actually the same as question 2, almost the same. Question 3, reschedule meetings for maximum free time. You're given an integer event time. You're given 2 integer arrays, start time and end time. And these would represent meetings not overlapping with meetings within your event time. You can reschedule one meeting by moving its start time to any other maintaining duration, such that the meetings are non-overlapping, to create the longest continuous period of free time during the event. So meetings in this version is valid for relative ordering of meetings to change after scheduling one meeting. Okay, so what this means is that it's more or less the same, very similar question. The difference is instead of moving k meetings around, you can pick only one meeting. You can put it anywhere. So for instance, here you can take this one meeting. You can take this one meeting. You can put it here. There's no other place to put it. You're essentially sliding it here. For this example, let me go. For this example, you can actually take this guy here, and then you can put it here. Turn on my pen. You can take this guy here. You can put it here. So that's something that you could not do in the previous example. The previous question. Previous question, you can only slide to the left or slide to the right. But here, you can take this, put it anywhere you want, anywhere there's a free space. So how do you tackle this? This is actually a much easier problem than the previous one. Essentially, for each block, the basic idea is to go through each block and you say, okay, what happens if I move this block away? Okay? What happens if I move this block away? First, you want to find out, is there a free space somewhere else? In this case, there's a free space somewhere else. You can move from here to here. In the earlier example, in this example, there's no free space, right? If you want to move this block, there's no free space. There's no free space anywhere else. There's no free space. There's no free space here. So the best you can do is slide it to the left or to the right. Okay? So you want to go through each block, and for each block, you want to say, is there a free space somewhere else in the event that I can move this block to? Or if there's no free space, I'll just slide this block to one side. That's the basic idea. So in order to do that, the first thing I did was to calculate all the gaps that we have. Okay, to calculate the gaps, you basically take the start time and minus the end time, the start time minus end time of the previous guy. And then what I did is I calculated the gaps along with their indexes. There's a reason why I need the index. I calculate the gaps along with the indexes. I sort them, and I only need 3 of the longest gaps. I don't need all the gaps. The reason why I need so many, I need more than one gap is, for instance, this guy, I want to see if there's a gap that is not adjacent to him. These don't count. I want to see if I can move him far away. So I need to keep track of at least 3 gaps. I find the longest gap. If the longest gap is next to me, the second longest gap is next to me, then I go on to the third longest gap. So I need at least 3 gaps. I put 5 because just to be safe. So I don't need to keep every single gap. Right. So the first step is I calculate all the list of gaps and I sort them. So for instance, in this case, I have a gap of 6. And it starts with index 1. I have a gap of 1 here. It starts at index 2. Here I have a gap of 2. Actually, my longest gap is here, 4 to 7. So it's a gap of 3. And it's at 0, 1, 2. And it is the left of index 2. So I calculate all the gaps, I sort them. And then that's the first step. The next step is for each block here, I calculate the size of my block and I calculate the space that I occupy. The space I occupy is the end time of the previous guy before me and the start time of the guy immediately after me. So for instance, in this guy, the space he occupies is from 1 to 7 and my size is 1. So once I've done that, I will check, is there a gap that I can move this guy to? Is there a gap I can move this one to? Yes, there's a gap somewhere here whose indexes, that's why I need the index, who is not next to me, whose indexes are not next to me. I can move this gap all the way to here. I can move this meeting all the way to this gap here and free up the entire space. So if I can move it, I can free up the entire space. In this example, when I reach here, I cannot find that there's no gap that is like far away from me, right? Even though I'm size 1, there's no gap here or here. The only two gaps are sort of adjacent to me. So the best I can do is to slide myself to one side. So if I'm not able to move this meeting far away, then my best call is the space that I occupy minus my width. So since I'm not able to slide this meeting somewhere else, the best I can do is keep it within the same space from 1 o'clock to 9 o'clock. I slide it to the end. So the best I can do is 8 minus 1, which is 7. Yeah, so I repeat all the way until I've checked every single block. And that will give me the best time. Yeah, let me look at the question. Count number of gaps bigger than a segment. Yeah. Subtract 2 adjacent gaps if bigger than a segment. You can form an interval between the previous and next block relative to I. Shift directly, yeah. So yeah, pretty much you just see if there's a gap somewhere else far away from you that you can fit, then you go somewhere else. If there's no gap, then you find what's the space you occupy. Left minus right minus yourself. Yeah, okay. So question 4. Yeah, question 4 is a DP, I'm pretty sure. It looks like some of you guys agree. Yeah. So question 4. You are given a string caption of length n. A good caption is a string where every character appears in groups of at least 3 consecutive occurrences. So AAA BBB, AAAA CCC, AA BBB, CCCC D. So these are good captions because they occur at least 3 consecutive times, and these are not good captions. These are not good captions. Okay, so what you want to do, I'm pretty sure, like you, okay, sorry, let me finish explaining the problem. You can perform the following operation any number of times. You can move a character to immediately before it or immediately after it. And your job is to convert the given caption into a good caption using the minimum number of operations and return it. If there are multiple possible good operations, captions, return the lexicographically smallest one among them. If it's impossible to create a good caption, return an empty string. Okay, so this is very clearly a dynamic programming problem. How do you know it's dynamic programming problem? Well, the hint is that if the problem, if you can sort of think of this, you know if it is a dynamic programming problem if solving for n minus 1 makes it easier to solve for n. So I have if I have a caption of length n, in this case 4, if I solve for n minus 1, if I have the answer to 3, That makes it easier to solve for length 4. That's how you know it's a dynamic programming problem. If you have if you solve the easier problem helps you solve the harder problem. In this case, it's pretty clear that it's a dynamic programming problem. And what you want to do is, I'm pretty sure, I haven't actually done it myself, is you want to keep track of all the good captions at a particular index and how much it costs. So for instance, at here, let's say I make this a little bit easier. So C. So at here, I have a good caption. It costs me 0 and it ends with C. Okay? So when I'm here, what I can do is I can I can check what are the good captions before me. There's only one good caption, ends with C, and it costs 0. Then I can do one of two things. I can do one thing basically. I can change this D into a C, and it's going to cost me 1. So my last character is a C, and it costs me 1. So when I'm here, I look at how many good captions there are before me. Because we only care about the last 2 characters. We only care about this one and this one. Essentially, what we need to do is to keep the last 2. We only care about this one and this one. We basically want to check if I change this, like how much will it cost to add me to create a good caption, right? So I can change this C. If I look at the one before me, there's a C and it costs 1. I can do nothing, and I have a valid caption that ends with a C and costs total 1. Or I can go 2 before to this C over here, and I want to see if I have a good caption. What I need to do is to change this D to something else, so it's also going to cost 1. So essentially what you want to do is you want to keep track of all the good captions that you can possibly get at each index and what they end with, and you look at the last 2 captions and what they cost, and you can use that to figure out what's the best cost for you, for what are all the valid captions that you can create up to this index that ends with a particular character. Yeah, sorry I'm rambling a bit. I hope that makes sense. Yeah. So rate finance, for every character at index I, there will be at most 26 characters. Yeah. So basically at every index I, you have to look at I-1 and I-2. You keep track of all the valid captions that end with I-1 and I-2 and what they cost. And you say, okay, I-2, if it ends with C, then what I want to do is I need to turn this into a C. I need to turn this into a C also. This is how much it's going to cost. So you have basically 26 captions. There's some tricky details to this that's like not obvious. There's some tricky details to this that are not obvious. You have to think about it a little bit. Because there's 3 and you want to keep only 26 rows in your DP. You don't want to keep 26 times 26, which you actually can. You can keep 26 times 26 rows, so you keep track of the last 2 characters. You can do that too. Okay, cool. So that's it for the live stream for today. Unfortunately, I managed to only get 3, but I was penalized pretty heavily. So I don't know how well I'm gonna do. Hopefully it's better than last time. I'm trying to get back to 2,000 rating. It's gonna be a slow jog. Either way, I'm gonna keep trying week after week, and I would be very happy if you guys come back week after week and try along with me. So that's the end of the live stream. Thanks a lot for joining. I'm a little sick today, so I'm gonna go rest up and relax a little bit. All right. See you all. See you next week.